first glance, the cigarette looks simple, small, ordinary, something millions of people see every day without a second thought. But behind this seemingly simple object exists one of the most complex, tightly controlled, and industrialized production systems ever created. This process does not begin in a factory. It begins in open fields. Across multiple continents, tobacco farming starts months before any machine ever moves. Farmers prepare soil with precise nutrient balances, adjusting pH levels to match the tobacco variety being grown. Seedlings are raised in controlled nurseries before being transplanted into vast agricultural fields where spacing, irrigation, and sunlight exposure are carefully managed. Tobacco is sensitive. Too much water weakens leaf structure. Too little reduces yield. Temperature fluctuations can alter nicotine levels. Every variable matters. As the plants mature, leaves are harvested in stages, not all at once. Lower leaves are collected first, followed by middle and upper leaves as they ripen. Each position on the plant produces leaves with different chemical compositions, and these differences will later influence blending. After harvesting, leaves are not immediately usable. They must be cured. Curing is where raw green leaves transform into usable tobacco. Depending on the type, leaves undergo air curing, flue curing, or fire curing. Large curing barns regulate airflow, temperature, and humidity over several weeks. During this time, chlorophyll breaks down, sugars develop, and the leaf changes color and texture. This is chemistry happening slowly and naturally. Once cured, leaves are graded. Skilled inspectors examine color, elasticity, size, and aroma. Leaves are sorted into categories, bundled, and prepared for transport. At this stage, tobacco is still raw material, valuable but unfinished. Baled tobacco is shipped to processing facilities where the industrial phase truly begins. Inside these facilities, the environment changes completely. Temperature and humidity are strictly controlled. Air filtration systems remove dust particles. Workers follow hygiene protocols similar to those used in food manufacturing. The first step is conditioning. Dried tobacco is brittle. Before it can be processed, moisture must be reintroduced. Conditioning chambers use steam and controlled humidity to soften the leaves, restoring flexibility without oversaturation. Once conditioned, leaves move to stripping machines. These machines separate the usable leaf lamina from the central stem. Stems are not wasted. They are processed separately and often reused after treatment. The lamina continues forward into cutting systems. High-speed cutters slice tobacco into fine, uniform strands. Precision is critical. Cut width affects burn rate, draw resistance, and taste consistency. Laser sensors constantly measure strand dimensions, making real-time adjustments. Now blending begins. Different tobacco varieties are combined according to proprietary formulas. These blends are closely guarded secrets. They define brand identity. Even minor deviations are unacceptable. Blending is followed by casing and flavor application. Contrary to popular belief, flavoring does not dominate the taste. It enhances consistency. Casing solutions, mixtures of sugars, humectants, and flavor compounds, are sprayed evenly while tobacco is gently mixed. This stabilizes moisture and balances taste. The tobacco is then aged briefly to allow flavors to integrate. From here, the material enters cigarette-making machines, some of the fastest industrial systems in existence. These machines operate at astonishing speed. Tobacco is fed onto moving belts where it is formed into a continuous rod. Paper wraps around the rod and is sealed instantly. This endless cigarette rod moves through cutting blades that slice it into precise lengths. Filters are produced simultaneously on parallel lines. Filter rods are formed from cellulose acetate fibers, bonded, wrapped, and cut. Ventilation holes are added using lasers to control airflow. Filters are then attached to tobacco rods with seamless precision. Within seconds, individual cigarettes exist. But production is not finished. Each cigarette passes through inspection systems. Cameras check length, density, paper integrity, and filter alignment. Defective units are removed automatically. Approved cigarettes move into packaging lines. Here, automation dominates. Cigarettes are grouped, wrapped, boxed, sealed, stamped, and labeled at extreme speeds. Packaging varies by market, warning labels, languages, tax markings, and branding differ globally. Every pack is traceable. Batch codes link each unit back to its production time, machine, and tobacco source. This traceability is critical for compliance and quality assurance. Finished cartons are assembled into master cases, stacked on pallets, and wrapped for stability. From here, products move into climate-controlled warehouses awaiting distribution. This is where manufacturing transitions into logistics. Advanced inventory systems manage stock levels across regions. Predictive analytics forecast demand. Production schedules adjust continuously. Shipments leave factories by truck, rail, sea, or air depending on destination. Containers are sealed, tracked, and monitored. Regulatory oversight intensifies. Customs inspections verify documentation. Taxes are calculated. Compliance checks ensure packaging meets legal standards. Once cleared, products enter national distribution networks. Wholesalers break down shipments and supply retailers. Automated systems track sales in real time. Each purchase sends data upstream, influencing future production. This feedback loop is constant. The scale is immense. Factories operate 24/7. Maintenance teams rotate continuously. Machines are serviced without stopping production. Even minutes of downtime cost millions. Energy usage is optimized. Waste is recycled. Efficiency is relentlessly pursued. What makes this system extraordinary is consistency. A cigarette purchased today must feel identical to one purchased years ago. Taste, draw, appearance, everything engineered, measured, controlled. Consumers see the final product. They never see the agricultural science, chemical engineering, mechanical precision, data analytics, or global logistics behind it. From sunlit fields to sealed cartons. From biological material to industrial output. From local farms to global markets. This is not just manufacturing. This is industrial orchestration at planetary scale. Once cigarettes leave the factory floor, the process enters its most invisible stage. This is where manufacturing becomes economics. At this point, cigarettes are no longer individual products. They are units inside a global system built for scale, predictability, and uninterrupted flow. Every shipment is planned weeks or months in advance, guided by consumption data, historical sales, and regional demand patterns. Nothing is random. Analytical teams forecast how many cigarettes will be consumed in specific cities and countries. These forecasts determine raw tobacco purchases, production volume, machine schedules, labor shifts, and transport routes. Even small errors can lead to massive oversupply or empty shelves. Cigarettes are among the most heavily taxed consumer goods in the world. In many countries, taxes make up most of the retail price. Governments rely on this revenue, creating a system where strict regulation and financial dependence coexist. To operate legally, manufacturers maintain complex compliance structures. Each market has its own rules, packaging formats, warning labels, tax stamps, languages, and distribution limits. Factories do not produce one universal product. They produce multiple legally distinct versions of the same cigarette, adapted for each destination. Inside distribution centers, finished cartons are scanned, sorted, and routed automatically. Shipments for different countries can never be mixed. Errors at this stage can cause major financial losses. Once shipments enter global transport networks, tracking is constant. Containers are sealed, GPS monitored, and documented at every step. Ownership often changes at distribution hubs, where wholesalers purchase inventory and taxes are applied. Retail sales drive the entire system backward. Sales data flows from stores to manufacturers and back to farms. If you enjoy seeing how massive systems really work, from raw materials to global scale, subscribe to the channel. More full process documentaries are coming. breaking down how the world's most powerful industries operate behind the scenes.